In this video we'll show you how we can machine this component. It's been imported as a step file, so the first thing to do is to set where we want the machining datum point to be. So if I rotate the model using the center mouse wheel, we can see that the X and Y axis is probably okay as being in the center, but we might need to do something with the Z axis to move the datum to the top of the job. So to do that we go into the milling tab and go to set origin, and the origin can be set to any of these positions, so we'll keep it to the X and Y midpoint and the Z maximum. Okay, so that shifts the datum point such that it's Z0 will be the top of the job. Now the thing about this sort of thing is to use the correct tools for the correct part. It could be possible to just select the base boundary and create a 3D part, a machining part for the whole thing, but it's probably best to break it down into using 3D strategy where it's necessary and a 2D strategy where it's best suited. So we'll look first at doing the cone part, which has a radius on it. So what we'll do first of all is we'll create the faces and then the sketches. So the pocketing and the profile command are all based on sketches. So to create a sketch we can use the existing features. If I right click the mouse and say pick faces, then I can pick that top face, right click and say make a sketch from the face. So that's now made a sketch which is just a 2D shape which we can use as the inner boundary for the 3D pocketing command. Now the 3D pocketing command will only take place around the cone, but I need to create a sketch of the base of that which will be useful. So I could use the face here, but that would give me a sketch which was the exact size, so we want the sketch to be bigger than the size we want. So if I was to choose this face here for instance and say make a sketch from the face, what we get there is, because the face was able to create two sketches, an inner and an outer, so that sketches both of those. So if we right click the sketch item in the objects tree here and say split the sketch, then we get one sketch for the outside and one sketch for the inside. So to combine those sketches with the sketch at the top, which is number 1, so that's the inside and that will be the outside. If I hold down the control key, right click and say combine sketches, then I get a single sketch which is the outside and the inside, which will act as the outer boundary and the inner island for the pocketing command. So we need to create a solid, a surface from the solid. So under the milling tab we just go to surface and we pick the solid. There is only one in this job, and we give it a tolerance. This is a coarseness factor, so if you're looking at doing very fine machining you might want to make a smaller tolerance, but for this type of shape, this is all in millimeters, 0.1 millimeter is perfectly adequate. So that creates a surface which we can use to create the 3D toolpath. If I look at the tools which I've got in my library, these are those. Now if I click on any one of them we can see the tools there. So perhaps we might want to use a 6mm ball nose end mill to rough that out. So we use the pocketing command and we'll set quite a large step over to start with. It's best to use a large step over to start with so that you get the machining that you want. You can then go back and change the step over and the coarseness factor for machining when you're happy that the machining is as you want it to be. If you set the step over and the step down to be a very small value, it'll just take that much longer to calculate. So to start with, it's best to use a larger value and to make sure that you've got the main parameters of the machining operation correct. Okay, so we're going to use a step over, say 1mm. We're going to start at the boundary as opposed to the centre. We're going to be climb milling. We're not going to use zigzag machining so that it will follow the shape of the outside contours. This is the tool we're going to use. The surface, there is only one surface that we've created. The clearance plane, as I click into any of these windows, you'll notice that the diagram here tells me and shows me what the value refers to. So the clearance plane is a value above Z0. Now in our case Z0 is the top of the job, so it's a clearance plane above that. The feed change plane is where the tool changes from rapid to feed rate. The work surface is where the top of the job actually is, which is in this case Z0. The final depth that we want to go to, you can measure this off the model or you can refer to a drawing. And the sketch that we want to use, if we know the name of the sketch we can choose it here, otherwise we can use the pick button here to pick the sketch, and then when we've chosen that we just press the enter key. So that's the sketch there, and this is the feed rate and the spindle speed for that operation. So that's now recalculating that operation. So this will depend on how fast or how slow your PC is for the calculation time. Okay, so that's calculated the tool path there. As I say, it's a bit coarse at the moment, but that's just so that I can check that it's actually machining exactly what I want it to do. Now one thing I will go back and do, under the pocketing command, if I double click it, I'm going to uncheck the box, keep the tool down, so that it will reverse, take the tool back to the clearance plane between each pass. So the way the pocketing command works is that it creates a pocketing command based on the 2D sketches. It then projects that onto the model. So if we look at it from the top, this is the step over that you can see there, and the step down is controlled only by the step over that we've set. Now if we wanted to set up different step downs for the roughing pass, then we can do that, but it's important to bear in mind that in cases like this it's the step over in X and Y which controls the coarseness factor. So if this was a roughing, that would be okay, but we might want a much smaller step for a finishing pass. Okay, so in that instance we'll just go back and we'll change the step over to say 0.5 of a millimetre and let it recalculate that. So as I say, the speed of your PC is important here, because the faster the PC, the faster the calculation time will be. Okay, so we can see the toolpath there. Now you notice that there are retractions between each pass, such that the tool, when it's machining one pass at the bottom and it goes up to the top, it's not doing a vector movement, it's doing a straight line in Z and then moving across in X and Y. That will avoid any gouging. Okay, so for this part of the video, that's the showing you the 3D part of the model.